Hello, welcome to the Chronicler, a channel where visualization of data explains so that we may decipher a brief economics from it. Agriculture in Africa has a tremendous social clout because of most people living in poverty rely their income on farming. For the first decade, Eswatini, Lesotho, and South Africa were leading the top three of vast agricultural nation. After that Burundi came to lead them for 2 decades. And finally, along with South Africa and Nigeria became as the top 3 of most arable countries in Africa for past 2 years. Unfortunately, poor countries cannot rely only on agricultural sector for their national income. According to worldpopulationreview.com, 3 from 5 of the poorest countries in 2020 are having agriculture more than 40% GDP, including Burundi. In contrast, top 5 of African richest countries trust in industrial sector and services to control their GDP, in which agricultural sector contribution solely below 5%. Emerging markets such as Equatorial Guinea, Seychelles, Mauritius, Gabon, and Botswana are respectively have the highest GDP per capita in Africa for 2020. Our data shows that the greater the agriculture land area coverage does not mean the higher the proportion agriculture in GDP. South Africa, Burundi, and Nigeria as the top 3 of the most arable country in 2020 are not on the top 3 of the country with highest agricultural value added in GDP. That's why become interesting to examine a little further about the relationship between GDP annual growth and growth of agricultural land value added in GDP starting from South Africa. Fortunately, the data plot suggests that we may continue to conduct regression. We are using Gretl, an easy and free econometrics software, to perform regression analysis. First, we have to obtain time series data related to GDP annual growth and growth of agricultural land value added in GDP, in our case, from 1961 to 2018, and save it into a text file. Second, open the certain text file so the Gretl may read it and define the variables. As Gretl has successfully read our data, we may proceed our regression. Go to menu bar, click on Model, then click Ordinary Least Squares. Let GDP annual growth as dependent variable and the annual growth of agricultural land value added in GDP as regressors. The results suggest that the regressor affects dependent variable in such way as 1% increase in growth of agricultural land value added will be followed by a decrease in GDP annual growth around 0.93%. In other words, we find an indication that agricultural value added is relatively inelastic to GDP growth. But we cannot surely take into account our regression model before testing the classical assumptions. Fortunately, Gretl has provided on-click test for it. At least we have to prove that our model is homoscedasticity, without autocorrelation, and surely linear. Let's do it one by one. First, click on Test in Model window. Choose White's test for heteroscedasticity. Regarding to null hypothesis that heteroscedasticity not present, p-value is above 0.05 so that we accept null hypothesis and conclude our model is homoscedasticity. Second, testing autocorrelation. Define lag number as equal to 1. Null hypothesis is no autocorrelation. With probability value as 0.798856, we may accept null hypothesis so that our model is free from autocorrelation. Third, testing linearity. Choose nonlinearity, squares, in test option. Probability is 0.477495 or above 0.05 so that we may accept null hypothesis. We conclude that our model is linear. Since we can prove that our model is not violating classical assumptions, we may calculate the elasticity through console command by typing certain command. The result is 0.964971. So that growth in agriculture value added is inelastic to GDP growth. Means agricultural sector increase in South Africa will positively affect GDP but in less number. I hope you enjoy the video. We will continue our regression analysis to Burundi and Nigeria in the next season. Have a nice day.